Welcome to Lucid Mind Chemistry channel. In this video, I have put together some questions related to the topic isomerism and its types. For links to other topics and question timestamps, please visit video description. Question 26. Alcohol X reacts with concentrated sulfuric acid to produce a mixture of products. Two of the products are structural isomers of each other. What could be X? Now you should remember the reaction. Alcohol reacts with concentrated sulfuric acid to form alkene along with the removal of H2O. Structural isomers are those compounds that have same formula, same molecular formula, but different structures. A is hexane 2-ol. In hexane we have 6 carbon atoms, and 2-ol means we have alcohol group on second carbon atom. Now in the presence of concentrated H2SO4, alkene is formed. That alkene could be either between these 2 carbon atoms or these 2 carbon atoms, because hydrogen is removed from adjacent carbon and H2O is removed. So first product could be this one. Second product could be this one if hydrogen is removed from this carbon and OH is removed from this carbon. Our first product is alkene, as double bond is between first and second carbon atom, so it is hex 1-ene. While in second product we have double bond between second and third carbon atom, so it is hex 2-ene. Both the products have same general formula C6H12, and the structures are different as the position of double bond has changed. So they are structural isomers of each other, so therefore A could be the correct answer. B is pentane 1-ol. In pentane we have 5 carbon atoms. 1-ol means that OH is attached with the first carbon atom. Now in the presence of concentrated sulfuric acid, water will be removed and hydrogen is removed from this adjacent carbon atom. As there is no other adjacent carbon atom, so therefore only one product is possible, which is this one. And the name is Pent 1-ene. For part C we have pentane 3-ol. It means that OH group is attached on the third carbon atom, and in total we have 5. Now hydrogen can be removed from this adjacent carbon atom or this adjacent carbon atom, so double bond could either come between these 2 carbons or these 2 carbons. 2 products are formed, and if the double bond is between these 2 carbon atoms, then this product is formed. While naming, we start numbering from the carbon that gives least number to the double bond. As we can see that the double bond is present on same carbon atom in these 2 products, so therefore these are not different products, they are the same. And the name for both is Pent 2-ene, along with water molecules that are removed. Last one is propane 2-ol. In propane we have 3 carbon atoms, and 2-ol means OH is on second carbon. So either hydrogen is removed from this corner carbon or from this corner carbon. So again both products are same, either this one or this one. The double bond is present between first and second carbon atoms, so therefore the name for both will be prop 1-ene, along with water molecules. As these are the same compounds, not the isomers, so therefore all these are incorrect. Correct answer is therefore A.
Question number 20. Which pair of compounds are functional group isomers of each other? Now, what is a functional group isomer? Functional group isomers are basically those compounds that have the same molecular formula but different functional groups involved. Let's see the answers. Part A says butane, 1-ol and butanol. This is butane, 1-ol. Butane consists of 4 carbon atoms and OH is attached to the first carbon. Butanol also consists of 4 carbon atoms and the functional group is aldehyde. Now let's see the number of hydrogen atoms on each of them. This one has 3 hydrogen, 2 hydrogen atoms, 2 hydrogens, 2 hydrogens. This carbon has 3, this has 2, this has 2. Now the total number of hydrogens in butanol and butanol is 3, 4, 5, 6, 7, 8, 9, 10. 10 with alcohol and 8 with aldehyde. So it means they are not isomers. B is ethyl propanoate and pentanoic acid. Let's draw the structures of ethyl propanoate. This is ethyl propanoate. This one is pentanoic acid. Now let's draw the number of hydrogens with each. 3, 2, 2, 3, 3, 2, 2, 2. So this one has 10 hydrogen atoms. This one has 10 hydrogen atoms. Both have 5 carbon atoms each, 2 oxygen atoms. So it means that they are functional group isomers because the functional group in both of them are different. One is ester and the second one is carboxylic acid. Now let's see how part C goes. It says hex 1-ene and hex 2-ene. So hex 1-ene means that the double bond is with is in between first and second carbon atom. This is hex 1-ene. And hex 2-ene means that the double bond is in between carbon 2 and carbon 3. As the functional group in both of them are same, so they are not functional group isomers, they are actually same alkene compound. D is propylamine. And propane nitrile. As you can see, the number of hydrogens are not equal, so therefore they are not the isomers of each other. Question number 25. Structural isomerism and stereoisomerism should be considered when answering this question. How many non-cyclic isomers? So we have to draw are the non-cyclic isomers. Have the molecular formula C5H10. So let's find out.
C5H10 means it is an alkene because the formula is CnH2n. So this alkene has 5 carbon atoms. Let's draw the double bond on the first carbon atom. As we know that there are 2 hydrogen atoms with the corner carbon, so the name is Pent1ene. And there is no Cis-Trans isomer. Because with the double bonded carbon atom, there are 2 hydrogen atoms. The atoms with the double bonded carbon must be different for a geometric isomerism. Now let's draw another one. Let's take double bond to the carbon 2. This is Pent2ene, and cis and trans both are possible for this one. Because the doubly bonded carbon has 2 different atoms attached directly with it. Let's draw the third one. Again I am taking Pent1ene and I am changing the long chain. So this will be 3-methyl but1ene. This is first carbon, this is second, this is the third one. Again, stereoisomer is not possible because corner carbon has 2 same atoms attached with it. So no cis-trans. Let's move this substituent to another place. So we have CH2 double bond C. Now the name of compound is 2-methyl but1ene, and again no cis-trans is possible. We can move double bond to the next carbon atom. It will be something like this. This is 2-methyl but2ene. Again no cis-trans isomers because the double bonded carbon has same atoms attached. Now counting, this is the first structure, this is the second one with cis and third one with trans, this is the fourth one, this is the fifth one, and this is sixth. So we have 6 non-cyclic isomers that are possible. So it means that the answer is D. Question 40. Which pairs are structural isomers of each other? Now by structural isomer we mean that having the same molecular formula but different structures. Let's first find the molecular formula. In one we have 6 carbon atoms, 12 hydrogen atoms and 2 oxygen atoms. For this compound the molecular formula is 6 carbon atoms, 12 hydrogen atoms and 2 oxygen atoms. Now the molecular formula of both is same And we can see in the first one we have carboxylic acid functional group, while in the second one we have ester functional group. So therefore they are structural isomers. For second option, we can find the molecular formula. There are 6 carbon atoms, so C6. For hydrogen, there are 3 hydrogens in the corners and 1 hydrogen with these carbons, so 14 hydrogens are there. For the second option, we have 6 carbon atoms. And 14 hydrogen atoms. The molecular formula is same. Let's name both of these. First one is so the name should be this, and this are the methyl groups, so 2, 3 dimethyl butane. For this structure we can say 3-methyl pentane. So the molecular formula for both is same while the structure is different, so therefore they are also structural isomers. For third option, we can see the molecular formula first. So we have 6 carbon atoms, 14 hydrogen atoms, 1 oxygen atom for this compound. For this compound we have 6 carbon atoms, 14 hydrogen atoms, 1 oxygen atom. Now let's name this one. In the first one we have OH group attached with this carbon atom, so this is an alcohol, while in second we have OH group attached to this carbon atom, so it is also an alcohol. So the name of this alcohol will be 1, 2, 3, 4, 5, 6. So we have hexane, and OH is attached to the third carbon atom, so hexane 3-ol. For this structure we can see 1, 2, 3, 4, 5, 6. Again it is hexane, and OH is attached to the third carbon atom, so it is hexane 3-ol. So both of these are actually the same compounds, they are not different, so therefore they are not the isomers. So the only correct options are 1 and 2, so therefore answer is B. Question 22. Which compound could show both Cis-Trans isomerism and optical isomerism? For Cis-Trans, 2 conditions must be fulfilled. One is that there must be a double bond present between carbon atoms, and second is that each double bonded carbon must be attached with 2 different groups or elements. If the same elements or groups are attached on one carbon atom, then it will not show Cis-Trans isomerism. Similarly, the condition for optical isomerism is that there must be chiral carbon that is present. Now, chiral carbon is the one that is attached with 4 different elements or groups directly. Let's find this. In A, we can see we have double bonded carbon atoms present. But with this carbon, similar groups are attached, so therefore this will not show Cis-Trans isomerism. And let's look on this one. We have this carbon atoms that is attached with 4 different groups. So one is this one, then we have Cl, then we have H and Br. So therefore this will show optical isomerism. Overall A is incorrect. In part B, we have double bond present. Again, with double bonded carbon we have different groups, elements in this case. With this, again we have different groups, so therefore this will show Cis-Trans isomerism. For optical isomerism, we can look on this carbon that is attached to 4 different groups or elements, so therefore B will show both Cis-Trans and optical isomerism. In part C, we can see there is double bond present between these 2 carbon atoms and different elements are attached. Similarly, different elements are attached on this side, so therefore this will show cis-trans isomerism. Now for optical isomerism, we can consider this carbon atom, and as it is attached with two similar elements, so therefore this will not show optical isomerism. In the last one, we can see we have double bond, but similar atoms are attached with double bonded carbon, so therefore cis-trans is not shown. We have this carbon and it will show optical isomer only. Correct answer is therefore B. Question 26. The structure of damascene is shown. This is damascene structure. In this structure we have alkene functional groups, carbonyl carbon. Including damascene, how many stereoisomers exist with this structure formula? So we have to find the stereoisomers. Now there are two types of stereoisomers. One is cis-trans and second one is having chiral carbon. In this structure, as we know, there is no chiral carbon because none of the carbon is attached to four different atoms or groups. So the only possibility is the presence of cis-trans isomerism. Now cis-trans is shown by double bonds. So there are three double bonds present, 1, 2 and 3. The first two alkenes are actually present in the ring structure, so therefore they cannot show cis-trans isomerism. The only alkene that can show cis-trans isomerism is this double bond. This carbon atom has one hydrogen atom on this side and one hydrogen atom on this carbon atom. So this is the trans isomer of damascene. So the cis isomer will be when two hydrogen atoms are on the same side. So we have cis damascene and trans damascene. So we have two isomers, so therefore option is part B. Question 27. How many isomeric esters have the molecular formula C4H8O2? Now let's draw this esters with this molecular formula. We have HC double bond OO. There are 4 carbon atoms, 2, 3 and 4. Now we can also make another structure, HC double bond OO, CH, CH3. Now the corner carbon has been shifted to this carbon atom, so the structure would be like this. In third structure, we can put a carbon atom on this side. So we have CH3, C double bond O, O, CH2, CH3. We can change the number of carbon atoms on this side. Now, as we have one carbon atom, let's draw with 2 carbon atoms. We have CH3, CH2, C double bond O, O and CH3. Now if we shift this carbon atom to this side, then what happens that this type of structure is formed, CH3, CH2, CH2, C double bond O, O, and only hydrogen atom is left on the other side. Now this is not ester, it is actually carboxylic acid, so therefore this structure will not be counted. Now the only possible structures are 1, 2, 3 and 4, so therefore the possible option is C. Question 21. Which statement is correct? 2,2-dimethylpropanoic acid is an isomer of propyl methanoate. 2-methyl-butane-2-ol is an isomer of hexane 3-ol. So this is the question about isomers. So just let's find out part A. We have 2,2-dimethylpropanoic acid. On second carbon we have 2 methyl groups, so it will be CH3, CH3, CH3 and COOH. Propyl methanoate will be HC double bond O, O, C, C, C. We have the carboxylic acid of 1 carbon atom and alcohol of 3 carbon atoms. Now the number of carbon atoms are 1, 2, 3, 4, 5. 5 for this one and 4 for this one. So these are not the isomers because the number of atoms are not equal. So let's move to part B. We have 2-methyl butane 2-ol. So on second carbon we have methyl group and also alcohol group. Number of hydrogens will be 3, 3, 2 and 3. Hexane 3-ol will be 6 carbon atoms. And on third carbon we have alcohol group. Hydrogens will be H3, 2, 2, H, 2, 3. Now we can count the number of atoms. We have 5 carbons in this one and 6 carbons in this one. So this is also not the example of polymer. So both A and B are wrong. Let's see part C. In part C we have 3-methyl butane 2-one. This is a ketone with 4 number of carbon atoms in the long chain. Carbonyl carbon is on second carbon and methyl group is on third carbon. Now the number of hydrogens 3, 3, 1 and 3. Pentanal means we have 5 carbon atoms, and as it is an aldehyde, so the carbonyl carbon is on the last carbon. Now 3 hydrogen with this, 2, 2, 2. Now we can count the number of atoms. We have 5 carbons, 10 hydrogen atoms, 1 oxygen atom. For this we have 5 carbons, 10 hydrogen atoms and 1 oxygen atom. So yes, they are the isomers of each other. So this could be the possible answer. Now part D. We have 3,3-dimethyl butane 2-one. So we have 4 carbon atom, and on the second carbon we have ketone, and on the third carbon we have 2 methyl groups. Now balancing with hydrogens. Pentane 3-one. We have 5 carbon atoms, and on third carbon we have carbonyl group, so it is a ketone. Counting the number of carbons, we have 6 carbons, 12 hydrogen atoms, 1 oxygen atom. We have 5 carbons, so therefore they are not the isomers. So the only option is C.
Question number 20. Structural and stereoisomerism should be considered when answering this question. Compounds X, Y and Z are shown. This is X, Y and Z. How many other isomers of C3H7ClO are there that are alcohols? Let's first draw the structures of X, Y and Z. In X we have 3 carbon atoms, 1 OH, 1 Cl and 1 hydrogen atom attached with the last carbon. Also with the Y we have 3 carbon atoms, and again in Z we have 3 carbon atoms. So X will be like this: 1, 2, 3 carbons, and with last carbon we have OH and Cl. For Y we have 3 carbons, and with the last we have OH and Cl. As for Z, we have 3 carbon atoms, and with the central carbon we have Cl and OH. In stereoisomerism we have 2 types. Either there should be Cis-Trans isomerism, which needs a double bond between carbon atoms, or the second one must be Optical Isomerism, which needs a chiral center. Let's draw the structures that are different than X, Y and Z. We have 3 carbon atoms,
where OH is attached with the second carbon and Cl is attached with the third carbon. 3 hydrogen atoms are with this carbon, 1 with this, and 2 with this one. As we can see that the central carbon is attached to 4 different groups. One is OH, one is hydrogen, one is CH3, and one is CH2Cl. So therefore this is chiral carbon. So there must be an optical isomer of this compound. The numbering starts from this carbon atoms. As the substituent gets the least number, we have 1, 2, 3. So the name is 1-chloropropane 2-ol. Another possibility is that we have 3 carbons and OH is attached with the first carbon atom and Cl is attached with the third carbon atom. Rest are the number of hydrogens. We have 2, 2 and 2 hydrogen atoms. As we can see that none of the carbon is chiral, so therefore there is no optical isomer for this compound. The name of this compound is 3-chloropropane 1-ol. Another possibility is that we have 3 carbons, OH is attached with the first carbon atom and Cl with the second carbons. Filling hydrogen, we have 2 hydrogens, 1 and 3. The numbering starts from this carbon atom, so we have 2-chloropropane 1-ol. The central carbon is attached with 1 hydrogen atom, 1 chlorine atom, 1 CH3 and 1 CH2OH. So all 4 groups are different, so therefore this is chiral carbon. And this must have an optical isomer. So we have 1-chloropropane 2-ol along with its optical isomer. We have 3-chloropropane 1-ol. Then we have 2-chloropropane 1-ol along with its optical isomer. So in total we have 5 new isomers that are being formed. So therefore answer is D. Question 20. The unsaturated hydrocarbon octa 1357 tetraene can display geometric isomerism. This is the compound. How many isomers exist? For geometric isomerism, there are 2 conditions. One is that there must be a double bond between 2 carbon atoms, and second is that the carbon atom making a double bond must have 2 different groups or elements attached. If same elements are attached, then it won't show geometric isomerism. So in the structure we can see that this carbon is making a double bond but it has similar atoms attached, so this won't show geometric isomerism. Again at the last we can see that this carbon is also making bond with the same atoms, so this won't be a part of geometric isomerism. So we have 2 double bonds present. There are 3 possibilities for this isomerism. Either both of these double bonds show cis-isomerism, or one of the double bond shows cis and the other bond shows trans. So it could be cis-isomerism or cis-trans isomerism, or both the double bonds show trans isomerism. The structures would be like this. For cis we can draw this is when both are cis. This is when one is cis, as similar atoms are present on the same side, and one is trans. This is when both are trans. So we can write cis, cis, as same atoms are on the same side. We can write trans, cis, or the other way around, we can say cis-trans. For third one, we can say trans-trans. So therefore, option B is correct. Question number 20. How many structural isomers are there of trichloropropane? We have C3H5Cl3. Let's draw the possible structural isomers. We have 3 carbon atoms, 1, 2, 3, and 3 chlorine atoms. Now chlorine atom can attach with hydrogen atom in a different manner. It could be like this. It makes 1, 2, 3 trichloropropane. Or it could be like this. The name would be 1,1,2 trichloropropane. We could also have this structure where all the 3 chlorine atoms are joined with first carbon atom. So the name would be 1,1,1 trichloropropane. Also, we can have 1 chlorine atom attached with the last carbon. So it will become like this. Now the name is 1,1,3 trichloropropane. In another structure, we can have 2 chlorine atoms attached with the central carbon and 1 chlorine atom attached with the first carbon. So it could be like this: 1, 2, 2 trichloropropane. Now we have 5 different structural isomers and no other structural isomer is possible, so therefore answer is C. Question number 21. Compound X does not show Cis-Trans isomerism. What could be the identity of compound X? In order for a compound to show Cis-Trans isomerism, there must be 2 conditions that should be followed. One is that the compound must have a double bond. And second is that there must be different elements attached with the carbon atom that is doubly bonded. A is 1,1,2 trichloropropane. Now let's find out the structure of this compound. We have propene, so 3 carbon atoms. Trichloro, so there are 3 chlorine atoms. One is on first carbon, second is also on first carbon, third is on second carbon. So 1, 1, 2 trichloropropane. And the double bond is in between first and second carbon atom. Let's find out the conditions. For condition 1, we have a double bond, so yes, condition 1 is met. For condition 2, there must be different elements attached with the double bonded carbon.
So we can see both elements are chlorine, so therefore they are the same elements, so condition 2 is not met. So therefore it does not show cis-trans isomerism. So it could be the possible option. Second is 1,2,3 trichloropropane. Again we have 3 carbon atoms for propene, and chlorine atoms are attached with first, second and third carbon respectively. So we have chlorine, 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 and the double bond could be on either side. Now with the first carbon atom we have 3 bonds, the fourth bond is being formed with hydrogen. On second carbon atom we have 4 bonds, on the third we have 2 hydrogen atoms. So let's find out the conditions. First condition is that there must be a double bond. Yes, there is a double bond. Second condition is that there must be different elements or compounds attached with the double bonded carbon. So we have different with the first one, different with the second one. So both conditions are met. So therefore B shows cis-trans isomerism. So it is not the possible option. Let's find out about C. C is 1-chloro-but-1-ene. So we have 4 carbon atoms. As it is 1-ene, so therefore the double bond is in between first and second carbon. And 1 carbon also consists of chloro, 1 chloro. Now rest of the hydrogen atoms, we have 1 hydrogen with this one, 1 with this, 2 with this, and 3 with this one. Now let's find out the condition. First condition is double bond. So yes, we have a double bond. Second condition is that different elements are attached. Chlorine and hydrogen are different. Again, hydrogen and this is the different. So therefore both conditions are met and it shows cis-trans isomerism. So therefore it is not the option. Let's find out the last one. It is 1-chloro-but-2-ene. So again we have 4 carbon atoms in the long chain, and on second carbon we have double bond as it is 2-ene. On first carbon atom we have chloro, 1 chloro, rest of the hydrogen atoms. Let's find out the conditions. First condition is met as there is a double bond. For second condition, 1 is hydrogen, 1 is this, 1 is hydrogen, 1 is this. So we can see both the carbon atoms, this one and this one, have different types of elements and compounds attached. So therefore both conditions are met. So it is an example of cis-trans isomerism. So the only possible option is A. Question 20. Structural isomerism and stereoisomerism should be considered when answering this question. How many isomers with the formula C5H10 have structures that involve pi bonding? Stereoisomerism could be cis-trans or optical. C5H10 is an alkene as it has 5 carbons and 10 hydrogens, so it is a pentane. Let's draw possible structures of pentane. We have 1, 2, 3, 4, 5. And the double bond could be between first and second carbon. So it is pent-1-ene. If the double bond is between second and third carbon, then it will become pent-2-ene. Now looking at the cis-trans isomerism, we have pent-1-ene, and in this one the double bonded carbon is making bonds with 2 hydrogen atoms. As both atoms are similar, so therefore pent-1-ene cannot show cis-trans isomerism. In pent-2-ene we can see that the double bonded carbon is making one bond with hydrogen atom and other bond with CH3, while the other double bonded carbon is making one bond with hydrogen and second bond with ethyl. So as both groups attached are different, so therefore pent-2-ene can show cis-trans isomerism. So it could be cis-pent-2-ene
or trans-pentene. Another possible structure that we can draw is the one in which double bond is between first and second carbon, and there are 4 carbons in the long chain, while the methyl group is attached with the second carbon atom. So it will be 2-methyl but 1-ene. We can change the structure like this. The methyl group could be attached with the third carbon atom, so the name will become 3-methyl but 1-ene. Another possible structure is this one, in which double bond is between second and third carbon atom and methyl group is attached to the second carbon, so the name will be 2-methyl but 2-ene. Now we can see that neither of these structure has any chiral carbon present, so therefore there will be no optical isomerism. Now the number of isomers are pent-1-ene, cis-pent-2-ene, trans-pent-2-ene, 2-methyl but 1-ene, 3-methyl but 1-ene, and 2-methyl but 2-ene. So 6 possible isomers are having double bond. Question 37. Which compounds have optical isomers? Now those compounds have optical isomers in which such a carbon is present which is attached with 4 different elements or groups. Let's look into the options. In 1 we can see that this carbon is attached with hydrogen OH, this whole group, and this C double bond OH. So this is chiral carbon. Again we can see that the second carbon, this one is also chiral as it is attached with 4 different groups. This one is also chiral. This one is not chiral because it is attached to 2 hydrogen atoms that are same. This is also not chiral because it is attached with oxygen with a double bond. So option 1 is correct. 2. We can see that this carbon is attached with one of the hydrogen atoms. So it is chiral. This carbon is attached to 2 hydrogen atoms, so it is not chiral. This is attached to 2 hydrogen atoms. Again, this is not chiral. This is attached with 1 hydrogen atoms and 3 other groups. One is this one is this one is this one. So this is chiral. Similarly, we can see that this carbon is also attached with 1 hydrogen atom and it has 4 different groups attached. So this is also chiral. Looking at this carbon, we can see that 2 similar groups are attached. Both are methyl groups, so this is not chiral. Again, CH3 is not chiral as it has same hydrogen atoms attached. So we can see there are 3 chiral centers in 2, so it can show optical isomers. Moving towards third one, we have this carbon which is double bonded, so it does not show optical isomer. This carbon is also double bonded. This is also making a double bond. This is also making a double bond. So none of the carbon atom is chiral, so therefore 3 will not show any optical isomer. As option 1 and 2 are correct, so therefore answer is B. Question 20. Which types of stereoisomerism are shown by 2,4-dimethyl-hex-2-ene? Let's draw the structure of 2,4-dimethyl-hex-2-ene. As we have hex, so it means 6 carbon atoms are in long chain. On second carbon we have double bond. On second carbon and fourth carbon we have 2 methyl groups attached. Rest are the number of hydrogen atoms. A. Both cis-trans isomerism and optical isomerism. As we can see that for cis-trans, the double bonded carbon must have two different groups attached. As with this carbon, we can see that both groups are same, so therefore cis-trans isomerism is not possible. For optical isomerism, we must have a chiral carbon. Chiral carbon is the one that have four different groups attached. So we have four different groups attached with this carbon. So therefore this will show optical isomerism. So cis-trans is wrong. Optical isomerism is correct. C is incorrect. The answer is therefore D. Question 21. Which pair of alcohols are isomers of each other? Now isomers means those compounds that have same molecular formula but different structures. In A we have butane 1-ol, so in long chain we have 4 carbon atoms for butane, and on first carbon we have alcohol group attached. Rest of the number of hydrogen atoms. So the molecular formula is C4H10O. Second is 2,2-dimethylpropane 1-ol, so in long chain we have 3 carbon atoms as it is propane, and on second carbon we have 2 methyl groups attached, while on first carbon we have alcohol group present. Rest are the number of hydrogen atoms. The molecular formula is C4H12O. As we can see, molecular formula is different, so A is incorrect. In B we have butane 2-ol. We have 4 carbon atoms in butane, and on second carbon atom we have OH functional group. Rest are the number of hydrogen atoms. The molecular formula is C4H10O. Second is 2-methylpropane 2-ol. As we have propane, so there are 3 carbon atoms in the long chain. On second carbon we have methyl group and also OH group. Rest are the hydrogen atoms. The molecular formula is C4H10O. As we can see, the structure is different and the molecular formula is same, so therefore B could be correct. For C we have pentane 1-ol and 2-methylpropane 2-ol, as this is the same one. Let's draw the structure of pentane 1-ol. In pentane we have 5 carbon atoms in long chain, and 1-ol means OH is attached with the first carbon. As we can see that the number of carbon atoms are 5, while in 2-methylpropane 1-ol the number of carbon atoms is 4. Therefore these are not isomers. In D we have propane 2-ol. In propane we have 3 carbon atoms, and on second carbon we have OH group attached. Molecular formula is C3H8O. As number of carbon atoms and hydrogen is different, so therefore D is also not isomer. Correct answer is therefore B. Question 37. Which compounds show geometrical cis-trans isomerism? For cis-trans, there should be two things. One, a double bond must be present. Second, the carbon atom making double bond must be attached with two different elements or groups. Let's draw this option 1. We have CH3 bonded with carbon. Also hydrogen is present. Then on second side we have CH3 and C2H5. Now as we can see, the double bond is present, and also the double bonded carbon is attached with two different groups on both sides, so therefore it will show cis-trans isomerism. Now drawing part 2, we have CH3, carbon, hydrogen is also present. Then we have carbon with hydrogen and CH2, CH2, CH3. Now we can see that double bond is present, and also double bonded carbon is attached with two different groups or elements on both sides. So therefore this will also show Cis-Trans isomerism. Option 3, we have C2H5. Hydrogen is also present with carbon. Then on second side we have C2H5 and hydrogen is present. Again double bond is present, and the carbon that is making double bond is attached with two different groups. This carbon is also attached with two different elements or groups, so therefore this will show Cis-Trans isomerism. As all three options are correct, the answer is therefore A. Question 21. X has the molecular formula C5H12O. X has a branched carbon skeleton and a secondary alcohol functional group. How many structural isomers fit in the description of X? Let's draw the branch structure of C5H12O. So we have 5 carbon atoms. 4 carbon atoms are in the long chain while fifth one is as a branch. Now we have secondary alcohol functional group also attached. Secondary alcohol means it is attached with the carbon atom that is directly attached with 2 carbon atoms. So this is the only position for secondary alcohol. Other structures of C5H12O could be like this. Or like this. This is wrong because in this one we don't have a branched carbon skeleton, and this is wrong because now we have tertiary alcohol as compared to secondary alcohol. So the only possible structure is this one. The answer is therefore A. Question 22. A new jet fuel has been produced that is a mixture of different structural isomers of compound Q. This is compound Q. Which skeletal formula represents the structural isomer of Q? Let's first find out the number of atoms present in Q. We have 9 carbon atoms in the long chain and 5 carbon atoms are as substituents. So in total we have 14 carbon atoms. Now let's look at A. We have 9 carbon atoms in the long chain, 5 carbon atoms as substituents. So in total we have 14 carbon atoms. In B we can see that we have 8 carbon atoms in the long chain, while 5 carbon atoms are as substituents. So in total we have 13 carbons. As for isomers, the number of carbon atoms should be same as the formula is same, so therefore B is incorrect. Now in C we can find out the total number of carbon atoms. There are 7 carbon atoms in the long chain, and we have 7 carbon atoms as substituents. So in total we have 14 carbons. Similarly in D we can see that nine carbon atoms are in the long chain and we have 5 carbon atoms as substituents. So 9 and 5 become 14. Let's find out the name of structure A, we have substituents on 2nd, 3rd, 5th, 7th and 8th carbon. In total we have 5 methyl groups, so it is pentamethyl. And in long chain we have 9 carbon atoms, so it is nonane. Similarly for D, we can name this. This is the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9 carbon atoms. Again we have substituent on 2nd, 3rd, 5th, 7th, 8th. In total we have 5 methyl groups, so it is pentamethyl. And 9 carbon atoms in the long chain, so it is nonane. So we can say that A and D are actually same compounds. Now naming part C, we have 1, 2, 3, 4, 5, 6, 7 carbon atoms in the long chain. Now on 2nd carbon, 4th, 5th and 6th we have methyl groups, so we can write 2, 4, 5, 6. As there are 4, so it is tetramethyl. On 3rd carbon atom we have isopropyl group. And in long chain we have 7 carbon, so it is heptane. Now we can look at the structure. In the given structure we had 1, 2, 3. On 2nd, 3rd, 5th, 7th and 8th we had 5 methyl groups, pentamethyl, and long chain was of 9 carbon, so we can write nonane. So as we can see that A is similar to the one given in the question, similarly D is the same, so C is the only one that is isomer because its structure is different. Question 20. There are 3 structural isomers with the formula C5H12. This is alkane. Which formula correctly represent these 3 structural isomers? In A we have 5 carbon atoms in long chain. Rest of the hydrogen atoms, there are 5 carbon, 12 hydrogens. Then we have 4 carbon atoms in the long chain and 1 carbon is present on 2nd carbon as a substituent. Again we have 5 carbon atom and 12 hydrogens. So this is structural isomer. Then we have this compound which is in such a way that this carbon makes 4 single bonds with 4 CH3. So this is also a possible structural isomer as the formula is same C5H12. So A could be the correct option. Now in part B, we have 5 carbon atoms in the long chain. The formula is C5H12. Structure will be like this. Then we have 5 carbon atoms and 1 carbon is in the form of branch as the long chain consists of 4 carbon atoms. This is also correct structural formula. In the third one again we have 5 carbon atom and this carbon is present as a substituent on this carbon atom. So the formula is C5H12. Now we can see that these two are similar. This is because numbering starts from the carbon atom having the least number given to the substituent. So this is 2-methyl-butane. And in this compound we are going to start numbering from this carbon as the substituent has the least number. So again this is 2-methyl-butane. So as these two compounds are similar, they are not structural isomers. Then in part C we have skeletal formula. 5 carbon atoms. As it is alkane, so the formula is C5H12. Then we have 4 carbon atoms in the long chain, and on second carbon we have methyl functional group. So again the molecular formula is C5H12. And in the third one again we have 4 carbon atoms in the long chain and substituent is present on second carbon. So both these are the same compounds, they are not isomers. This is 2-methyl-butane, this is also 2-methyl-butane. In part D we have substituent on second carbon. Then again we have substituent CH3 on second carbon. So both these are actually same, both are 2-methyl-butane, so therefore D is also incorrect. The only option in which all three are different structural isomers is A. Thanks for watching. If this was useful, please do like, subscribe and share.